Right, you are now on question number 13. It reads, sketch on the same axis the graphs of y is equals to x squared minus 2 in modulus and y is equals to modulus of x, 3 marks. Right, so let me start by y is equals to modulus of x squared minus 2, something like this, right? So we need to find the intercepts. First, the values of y when x is 0 and the values of x when y is 0. Since it is a quadratic, we are likely to have two different or two distinct roots, something like this, right? So what is the value of y when x is 0? So you are putting 0 on x squared, you get modulus of the x squared becomes 0, modulus of minus 2, which is good as 2. Remember, if you have a negative number in a modulus, you treat it as a positive number. So modulus of minus 2 is 2. So here you write 2, you don't write minus 2. Be very careful. So our first point is 0 and 2. I hope you are following. Right? Now I want to find the values of x when y is 0. So you say 0 is equals to modulus of x squared minus 2, something like this. Raise both sides with power 2. 0 squared is 0. Here you get x squared minus 2 squared. Then raise both sides, create square root both sides. You get 0 is equals to x squared minus 2. Since square root of 0 is 0, and square root of x minus 2 squared is x minus 2. Now moving minus 2 to the left, you get 2 is equals to x squared. Then create square root both sides. Here you put plus or minus. So x is equals to root 2 or negative root 2. So we have root 2 here. We have negative root 2 here as our intercepts. Right, so let me draw the Cartesian plane. Where 0 represent the origin, something like this. Right, so here I'm going to put root 2. On the left side, I'm going to put negative root 2, trying to make sure that the distance from 0 to root 2 is same as the distance from 0 to negative root 2. Then do not forget that we have a point here, which is 0, 2 here. So it means if x is 0, we have a 2 over there. Right. So remember, for this modulus, we do not have negative values of y. It means you start by drawing this curve here first. Then you put this 2 as well. So this is the graph of y is equals to modulus of x squared minus 2. You are home and dry. We move on to the second one, modulus of x. This one is simple. It's very simple. Why? Because when x is 0, putting 0, you get y is equals to 0. So it is passing through the origin. This is our origin here. I hope you are following. So this one comes like this. You just need to make sure that the gradient on this, the angle on this side and the angle on this side are equal. So this is y is equals to modulus of x. Then you are home and dry. I hope you are following. Let us move on to part B of the question. It reads, hence or otherwise solve the equation. We need to solve this equation. Modulus of x squared minus 2 is equals to is equals to modulus of x, something like this. So when solving modulus equations, you start by raising both sides with power 2. Raise both sides with power 2 first. Right. So here you get x squared minus 2 squared. On this one, you get x squared. Move x squared to the left. You get x squared minus 2 squared minus x squared is equals to 0. I hope you are following, class. Right, then apply the difference of two squares. Square root of x squared minus 2 squared, you get x squared minus 2. Then you put negative. Square root of x squared, you get x. It means on this side, you put x squared minus 2 plus x, something like this. This is difference of two squares. Right. So on the left side, you get x squared minus x minus 2. On the right side, you get x squared plus x minus 2 is equals to 0. So we now want to solve the two equations. Here say is equals to 0, or x squared plus x minus 2 is equals to 0, something like this, right? So do we have factors on the left? Yes, we have. This can be factorized. You get x plus 1, you get x minus 2 is equals to 0. 1 minus 2, you get minus 1. 1 times minus 2, you get minus 2. So you get x is equals to minus 1 from this first bracket, or x is equals to 2 from the second bracket. I hope you are following. Can this be factorized? Yes, this one can be factorized as well. You have the factors plus 2 and x minus 1. 2 minus 1, you get 1. 2 times minus 1, you get minus 2. So here you get x is equals to minus 2 from the first bracket, or x is equals to 1 from the second bracket. So these are the solutions. I hope you are following. Let us move on to the next. State the range of values of x. So this one is very simple. You can draw your number line. Right, we have negative 2 as the smallest, followed by negative 1, followed by 1, and followed by 2. So this is x is greater than 2. This is 1 less than x less than 2. This is minus 1 less than x less than 1. This is minus 2 less than x less than minus 1. And this is x is less than minus 2. Something like this. So we just need to choose one region. Like what I told you, it's either the pattern is star, mark, star, mark, star, mark, or it's mark, star, mark, star, mark. So it means we just need to test one, and the one is going to give us the reaction of other regions. So let me choose a region with the 0 here. There is 0 between minus 1 and 1. So we need to check whether the region is true or false. So we would like to put 0 on this factorized expression. On the first bracket, you will remain with negative 2. On the second bracket, you will remain with negative 2. Negative 2 times negative 2, it gives you 4. Then the inequality that we have is lesser. So for 4 to be less than 0, it's false. So it means we don't want this region. So this region is correct, this one is correct, this one is wrong, and this one is wrong. So it means the adjacent regions must not be both correct or must not be both wrong. If this one is wrong, the neighbors are correct. We don't have a situation whereby we have two correct regions or two wrong regions next to each other. So if you test this one region, you would then have a reaction of the remaining regions. So your answer is -2 less than x less than -1 union 1 less than x less than 2. Then you are home and dry. I hope you are listening, class. Right.